Look up at the night sky. What do you see? Stars, planets, maybe a galaxy, a faint smudge of light millions of light years away. For all of human history, we have stared into that darkness filled with wonder. We are a curious species. It's in our DNA to ask questions. Where did we come from? Where are we going? And perhaps the biggest question of all, where does it all end? The idea of an edge to the universe is something that pulls at the very fabric of our imagination. It speaks to our deepest need to understand our place in the cosmos. It challenges us to think beyond our small terrestrial experiences and to embrace the vastness of reality. The concept of an edge is simple here on Earth. You can stand at the shore of an ocean, and that is an edge. You can climb to the peak of a mountain and see the edge of a valley. But in space, things are different. The universe doesn't have an edge you can fall off of. It's not a box with walls. When we talk about the edge of the universe, we are talking about the limits of our own vision. We are talking about a boundary not of space, but of time and light. It is the farthest point from which light has had enough time to travel across the cosmos and reach our telescopes here on Earth since the universe began. This cosmic boundary isn't a physical wall, but a horizon of information. Imagine you are on a ship in the middle of a vast ocean. You can see the horizon in every direction. That horizon is the limit of your sight. Is there nothing beyond it? Of course not. There is more ocean, more water, perhaps distant lands. But from your vantage point, the horizon is your edge. The universe is like that ocean. We are on a tiny ship called Earth, and our telescopes can only see so far. The edge we perceive is a product of our location and the finite speed of light. It's a profound and humbling thought. So, when we embark on this journey to the edge of the universe, we are really embarking on a journey to the beginning of time. We are peeling back the layers of cosmic history, one galaxy at a time, 1 billion years at a time. This quest is not just about astronomy, it's about our own origins. The elements in our bodies, the iron in our blood, were forged in the hearts of stars that have long since died. By looking out to the farthest reaches of space, we are looking back at the cosmic crucible that created the building blocks of everything we know and love. The universe is our story, and its edge is the first chapter. Let's try to wrap our minds around the scale of what we can see. We call it the Observable Universe. This is our cosmic neighborhood, the sphere of space from which light has had time to reach us. It's everything we have ever seen, or could ever hope to see, with our most powerful instruments. But how big is it? The numbers are staggering, almost beyond human comprehension. The observable universe is estimated to be about 93 billion light-years in diameter. A light-year is the distance light travels in 1 year, which is nearly 6 trillion miles. Now, multiply that by 93 billion. The result is a number so large it loses all meaning in our everyday lives. Think about it this way. The light from our sun takes about 8 minutes to reach Earth. The light from the next nearest star, Proxima Centauri, takes over 4 years. To cross our own Milky Way galaxy would take 100,000 years traveling at the speed of light. And our galaxy is just one of hundreds of billions, perhaps trillions within the observable universe. Each of those galaxies contains billions of stars, and many of those stars likely have planets of their own. Our universe is not just big, it is unimaginably vast, teeming with worlds and possibilities that stretch the limits of our imagination. This 93 billion light-year measurement might seem confusing. If the universe is about 13.8 billion years old, shouldn't the observable universe be 13.8 billion light-years away, in any direction, making the diameter twice that, or 27.6 billion light-years? The reason it's so much larger is because the universe itself has been expanding the entire time. The space between us and that distant galaxy has been stretching. So, while the light from a faraway object traveled for 13.8 billion years, the object that emitted it is now much, much farther away from us due to the expansion of space itself. This incredible scale redefines our place in the cosmos. On this little blue dot, we often feel like we are the center of everything. But the observable universe shows us that we are just a tiny part of an immense cosmic tapestry. We live in an ordinary spiral galaxy, in an unremarkable corner of a supercluster of galaxies, which is itself just one of many. This perspective is not meant to make us feel small or insignificant. Instead, it should fill us with a sense of awe and connection. We are part of this grand unfolding cosmic drama, a piece of the universe that has become self-aware. Every direction we look, there is a boundary. We call it the cosmic horizon. This is not a place, but a moment in time. It is the farthest distance we can possibly see, defined by the age of the universe and the constant speed of light. Light travels incredibly fast, but it is not instantaneous. When we look at distant objects, we are not seeing them as they are today. We are seeing them as they were in the past. The light from the Andromeda galaxy, our closest galactic neighbor, takes about 2.5 million years to reach us, so we see Andromeda as it was 2.5 million years ago. We are in essence looking through a time machine. The farther we look into space, the deeper we look into the past. With our most powerful telescopes, like the James Webb Space Telescope, we can see galaxies as they were more than 13 billion years ago. These are some of the first galaxies to ever form, infant structures of stars and gas emerging from the cosmic dawn. The light from these ancient galaxies has been traveling across the expanding universe for nearly its entire history just to reach our detectors. It's a faint, ancient message from a time when the universe was young, chaotic, and very different from the one we know today. So what happens when we try to look even farther? What happens when we push our gaze to the 13.8 billion year mark? We reach our cosmic horizon. This is the point where we are looking back to the very beginning of the universe. Any light from objects beyond this horizon simply has not had enough time to complete its journey to Earth. It is still traveling through space, on its way to us, but it hasn't arrived yet. This creates a perfect sphere around us, with Earth at its center, that marks the boundary of everything we can ever observe. It is the ultimate limit of our vision. It's important to remember that this horizon is relative to us. An observer in a galaxy a billion light-years away would have their own observable universe, with their own cosmic horizon. They would see parts of the cosmos that are invisible to us, just as parts of our observable universe would be invisible to them. There is no single center to the universe. Every point can be considered the center of its own observable sphere. This idea shatters our geocentric intuitions and forces us to accept a more democratic and awe-inspiring view of the cosmos. Every observer, everywhere, is at the center of their own known world. Here is a cosmic speed limit that is often misunderstood. Nothing can travel through space faster than light. But this rule doesn't apply to the expansion of space itself. Space is not a thing. It is the stage upon which the cosmic drama unfolds, and that stage is getting bigger every second. This idea, called cosmic expansion, was one of the most revolutionary discoveries of the 20th century. It means that the fabric of space-time itself is stretching, carrying galaxies along with it for the ride. Think of raisins in a loaf of baking bread. As the dough expands, all the raisins move farther apart from each other. Early in its history, just a tiny fraction of a second after the Big Bang, the universe underwent a period of mind-bogglingly rapid growth called cosmic inflation. During this period, the universe expanded exponentially, growing from a size smaller than an atom to larger than a galaxy in less than the blink of an eye. This expansion was faster, much faster than the speed of light. It didn't violate any laws of physics because nothing was traveling through space. Rather, space itself was being created and stretched at an astonishing rate. Inflation smoothed out the universe and set the stage for the structures we see today. Even now, the universe continues to expand, and the expansion is accelerating. Galaxies that are very far away from us are receding at incredible speeds. In fact, galaxies beyond a certain distance, known as the Hubble sphere, are moving away from us faster than the speed of light. This means the light they emit today will never be able to overcome the expanding space between us to reach Earth. We are causally disconnected from them forever. We can still see the light they emitted in the past when they were closer, but their future is forever hidden from us. This concept is both humbling and a little bit sad. It means that over billions of years, galaxies will disappear from our view, one by one, as they cross this cosmic event horizon. The night sky of the far future will be a much emptier, darker place. Our descendants will look up and see only the stars of our own local group of galaxies, huddled together against the encroaching darkness. The rest of the universe will have expanded beyond our reach, its light stretched into oblivion. We live in a special time, a cosmic golden age, where we can still witness the grandeur of the universe in its full glory. If we point our telescopes to the farthest reaches of space, in any direction we choose, we eventually hit a wall. It's not a brick wall, but a wall of light. This is the cosmic microwave background, or CMB. It is the oldest light in the universe, a faint afterglow from the Big Bang itself. This light was released about 380,000 years after the universe began. Before that time, the universe was a hot, dense, opaque soup of charged particles and radiation. Light couldn't travel freely. Photons were constantly scattered by electrons, kind of like light in a thick fog. The entire universe was a glowing, impenetrable plasma. As the universe expanded, it cooled. When it cooled to a certain temperature, about 3,000 degrees Kelvin, protons and electrons could finally combine to form neutral hydrogen atoms. This event is called recombination. Suddenly, the universe became transparent. The photons that had been trapped in the cosmic fog were set free, and they have been traveling across the universe ever since. The CMB is a snapshot of the universe at that exact moment of liberation. It is the surface of last scattering, the point in time beyond which we cannot see using light-based telescopes. It is the ultimate baby picture of our universe. When this light was first released, it was intensely hot and bright, like the surface of a star. But over the last 13.8 billion years, the expansion of the universe has stretched the wavelengths of this ancient light. It has been redshifted all the way from visible and infrared light into the microwave part of the electromagnetic spectrum. That's why we call it the cosmic microwave background. Your old television set, when tuned between stations, would pick up a tiny fraction of this cosmic static. A small part of that snow was interference from the birth of the universe. Studying the tiny temperature fluctuations in the CMB is one of the most powerful tools in modern cosmology. These minuscule variations, just a few parts per million, represent the seeds of all future structure. The slightly denser regions in this ancient plasma were the gravitational anchors that would eventually grow into the galaxies and clusters of galaxies we see today. The CMB is not just a barrier to our vision, it is a treasure map. It tells us the age of the universe, its composition, and its history. It is a direct link to our most distant cosmic origins. So what lies beyond the cosmic microwave background? What exists past the edge of our observable universe? This is where science, enters the realm of speculation, guided by mathematics and theory. The simplest and perhaps most likely answer is more of the same. More space, more galaxies, more stars, more planets. Our observable universe is just one patch of a much larger, possibly infinite cosmos. There is no physical edge or boundary. The universe just keeps going, stretching on and on forever. From our perspective, it is endless. If the universe is truly infinite, then the laws of probability suggest something extraordinary. With an infinite number of galaxies and planets, every possible configuration of matter must exist somewhere. That means that out there, somewhere beyond our horizon, there is another planet exactly like Earth. And on that planet, there is a person exactly like you, reading this exact essay. And another one, and another one. An infinite number of copies of you living out every possible variation of your life. This idea, born from the marriage of cosmology and statistics, is as mind-bending as it gets. But what if the universe isn't uniform? What if things change beyond our horizon? Some theories propose that the laws of physics themselves could be different in other domains of the universe. Perhaps the fundamental constants that govern our reality, like the strength of gravity or the charge of an electron, are not universal. In another cosmic domain, far beyond our sight, these constants could have different values, leading to a universe that would be utterly alien and unrecognizable to us. A place where stars might not form, or where atoms themselves could not exist. These are not just wild guesses. They are possibilities that arise from our best theories about the nature of reality, like string theory and cosmic inflation. The theory of eternal inflation suggests that our Big Bang was not a one-time event. Instead, our universe might be just one bubble that inflated out of a larger, eternally inflating space-time. Other bubbles could be constantly forming, each giving rise to a new universe with potentially different physical laws. Our universe could be just one island in a vast cosmic ocean of other universes. This idea of bubble universes leads us to one of the most profound and controversial concepts in all of science, the multiverse. The Multiverse Hypothesis suggests that our universe is not the only one. Instead, It is just one member of a vast, perhaps infinite, collection of universes. These other universes could be completely separate, existing in dimensions beyond our own, forever inaccessible. Or they could be right next to ours, separated by a membrane of space-time, as some versions of string theory predict. The possibilities are as limitless as the multiverse itself. What would these other universes be like? Some might be very similar to ours, with only minor differences. Others could be wildly different. Imagine a universe with 2 dimensions of time instead of 1. Or a universe with a much stronger force of gravity, where everything would be, well, crushed into black holes. Or a universe where the weak nuclear force is different, preventing stars from igniting and shining. The multiverse could be a cosmic laboratory where every possible set of physical laws is tested. Most of these universes would likely be sterile and empty, unable to support complexity or life. This raises a fascinating question. Why is our universe so perfectly tuned for life? The values of the fundamental constants seem to be exquisitely balanced. If you were to change the strength of the electromagnetic force by just a tiny amount, stars wouldn't be able to create carbon, and life as we know it would be impossible. This fine-tuning problem has puzzled physicists and philosophers for decades. The multiverse offers a potential solution. If there are countless universes, each with random physical laws, it's not surprising that at least one, ours, would happen to have the right conditions for life to emerge. We simply live in one of the universes where we could exist. Is there any way to test this idea? It's incredibly difficult, because by definition, these other universes are beyond our ability to observe directly. However, some scientists are looking for indirect evidence. For example, if our universe collided with another bubble universe in the distant past, it might have left a faint signature, a sort of cosmic bruise, in the cosmic microwave background. Scientists are scouring the CMB data for such anomalies. For now, the multiverse remains a compelling but unproven idea, a tantalizing glimpse into a reality that might be far grander and more complex than we ever imagined. Why do we do this? Why do we build massive telescopes and spend decades searching for faint signals from the dawn of time? Why do we grapple with ideas like infinite universes and cosmic horizons that seem to have no bearing on our daily lives? It is because we are human. We have a fire inside us, a spark of curiosity that has driven us since our ancestors first looked up at the stars and wondered what they were. This relentless drive to explore, to understand, and to know is one of the noblest aspects of our species. The quest to understand the universe is a journey of self-discovery. When we study the cosmos, we are also studying ourselves. The story of the universe is our story. The carbon in our cells, the calcium in our bones, the oxygen we breathe, all of it was forged in the fiery hearts of stars that lived and died long before the Earth was born. We are, in the most literal sense, stardust. We are the universe made manifest, capable of contemplating its own existence. This is a profound privilege and a great responsibility. This journey is not easy. The universe does not give up its secrets willingly. Every new discovery is the result of countless hours of work by dedicated scientists, engineers, and thinkers. It requires patience, persistence, and a willingness to be wrong. Science is a process of constant refinement, of questioning old ideas and embracing new evidence, no matter how strange or counterintuitive it may seem. It is a deeply human endeavor, full of triumphs and setbacks, but always pushing forward, driven by that unquenchable thirst for knowledge. And what we find on this journey changes us. Learning that the Earth is not the center of the universe, that our galaxy is one of billions, and that our observable universe may be just a tiny speck in a vast multiverse, these are humbling revelations. They strip away our cosmic arrogance and replace it with a sense of wonder and interconnectedness. They teach us that we are part of something much, much bigger than ourselves. This perspective is essential for our survival. It encourages us to look beyond our petty squabbles and to work together as a species, as inhabitants of a single, fragile planet in a vast and mysterious cosmos. We stand at a remarkable moment in human history. We have learned more about the universe in the last century than in all the millennia that came before. We have peered back to the dawn of time, mapped the afterglow of creation, and discovered a cosmos filled with more wonders than our ancestors could have ever dreamed of. And yet, the more we learn, the more we realize how much we still don't know. The edge of the observable universe is also the edge of our knowledge. Beyond it lies the great unknown. a realm of pure possibility. Will we ever know for sure what lies beyond our cosmic horizon? Perhaps not. Some questions may be forever beyond the reach of our science. The nature of an infinite cosmos, or the existence of other universes, might remain in the realm of theory and philosophy. But that is okay. The value of the quest is not just in finding the answers, but in the act of asking the questions. It is the pursuit of knowledge itself that enriches us, that expands our minds, and that elevates the human spirit. The journey is the destination. The universe is under no obligation to make sense to us. It is vast, complex, and often strange. But it is also beautiful. There is a deep and profound beauty in its laws, from the elegant dance of gravity that holds galaxies together to the quantum rules that govern the subatomic world. There is beauty in a spiral galaxy, in a star-forming nebula, and in the faint ancient light of the cosmic microwave background. This is the universe that we are privileged to inhabit, and our ability to appreciate its beauty is one of our greatest gifts. So, I invite you to keep looking up, keep asking questions, keep feeding that spark of wonder. The universe is the grandest story ever told, and we have only just begun to read it. What lies beyond the edge is a mystery, and perhaps it will always be so. But that mystery is not something to be feared. It is an invitation. It is a call to adventure for the mind and the spirit. It reminds us that no matter how much we learn, there will always be new frontiers to explore, new wonders to discover, and new mysteries to contemplate in the magnificent, endless cosmos.